Okay, so we're going to look at this second example, okay? So, part 2, x plus 2 over x subtract 1 is less than 3 and x cannot be equal to 1. And I'll explain why that is in a second. Okay. The reason x can't be equal to 1 is, if I put in 1 for x there, what do I get along the bottom? That 1, x can't be 1 because you get 0 along the bottom. Now, right, so, if we see an equation like this, generally we want to get rid of the fraction, yeah? So, what do I multiply both terms by here to get rid of the fraction? Now, here's the problem. It's not x minus 1, and there's a reason it's not x minus 1. We have a problem here. We know when we multiply an inequality by a negative number, what happens to the sign? The inequality sign flips over. This could possibly be a negative number. We don't know. Depending on the value of x, this could actually be a negative number. So we don't know whether we should flip the sign or not. So to get round this, okay, what we do is we multiply by a number that we know cannot be negative. What could I do to x minus 1 to ensure that it cannot be negative? Square it. I'm going to multiply across by x minus 1 to be squared. Because can any square number ever be negative? No. So that's how we get around this problem, okay? We multiply by x minus 1 to be squared. So I'm going to write this out, you can take it down, as x minus 1 could be positive or negative. We multiply both sides by x minus 1 to be squared. Which is positive. Okay, so that gets us out of that problem that we just encountered. So what we have then is x plus 2 over x minus 1 less than 3, and we're now going to multiply both sides by x minus 1 to be squared, which gives me x minus 1 squared by x plus 2 all over x minus 1, that's the left hand side, less than 3 times x minus 1 to be squared. Both sides are multiplied by x minus 1 squared. Now folks, if we just look at the left hand side here for a second, do we have a common factor here? What is it? X minus 1. So what I'm essentially left with on the left hand side is x minus 1 by x plus 2 less than 3 times, let's square out this, it's a perfect square, so I can square the first term. X by itself is x squared, twice the first term by the second, 2 by x by minus 1 is minus 2x, and square the last term plus 1. Okay, now I'm going to multiply that out to give me, okay, on the left hand side when I multiply out I get x squared plus x minus 2 is less than 3x squared minus 6x plus 3. That all okay so far? Okay, now let's look at what we have. We have an x squared on one side and a 3x squared on the other side. Now we're going to bring everything to one side, okay, and then let it equal 0 and follow our steps that we had previously. However, what I'm going to say is, before we do that, I want the x squared to be positive. Which side has more x squareds on it? The right hand side. So bring everything to the right hand side because it's to end up with a positive x squared then, okay? So that gives 0 less than 3x squared minus x squared minus 6x, when your plus x goes across it becomes minus x, and plus 3, your minus 2 comes across, it becomes plus 2. 0 less than 3x squared, it's not 3x squared, it's 2x squared, minus 6x minus x is minus 7x, plus 5 equals 0. Now I'm just going to, sorry, not equals 0, we're going to leave that out for a second. 0 less than 2x squared minus 7x plus 5. I'm just going to change that around. That's the same as 2x squared minus 7x plus 5 greater than 0. Okay. Okay. So from here on in, can I follow the steps we had previously? Yeah. So the first thing to do is replace the inequality sign with an equals. So I get 2x squared minus 7x plus 5 equals 0. I now factorize. So I get 2x and x equals 0. Factors of 5, yeah, combined with 2x and x to give me minus 7. Well, that's minus 1 plus 5. So 2x add 5 equals 0, or x subtract 1 equals 0. That gives me 2x equals minus 5. Divide both terms by 2, you get x equals minus 5 halves. Or x minus 1 equals 0, therefore x equals 1. Huh? Sorry, it is minus 5, isn't it? My apologies. It's minus 5 and minus 1, isn't it? Yeah. Wrong signs. Minus 5, minus 5. So that would give me a positive 5 halves and positive 1. So I have my two solutions now. What does that mean graphically? It's where what happens? The curve. What's happening at these 2 points? Crossing the x-axis. So let's go and graph it. Okay, I'm going to do a quick sketch just to help me find a solution set for this inequality. So we're crossing the x-axis at 1, and we're crossing the x-axis at 5 halves, which is 2.5. So there's 1, there's 2, I'll put in 3 and 4. Okay, so 2.5 is approximately here, and x equals 1 we know is there, and we know the graph is symmetrical, therefore the vertex, the bottom of the graph, will lie between these two, so it'll lie at about here, and then I just draw up my graph. Okay, now we go back to the original equation. We were looking for where it is greater than or equal to, no, just greater than 0. So any of these x values along here, if I sub them into the function, the inequality, will make it greater than or equal to 0. So we need to write this down, the solution set. Therefore the solution is x can be less than 1 or x can be greater than 5 halves.